Okay, let's dive into this. Imagine you're looking up at the night sky and you realize that one of those faint, icy streaks you're seeing didn't actually come from our neighborhood. Like, it didn't come from anywhere even remotely close. Today, in this explainer, we're taking a look at 3I/Atlas. This is the third confirmed interstellar object to ever pass through our solar system. Discovered in July 2025, you really have to understand that this isn't just another comet. It is a profound cosmic anomaly, and it fundamentally shifts our understanding of the universe.
Which brings us to the ultimate question for today. What happens when a 14-billion-year-old wanderer literally crashes into our solar system? To really appreciate what's going on here, we have to frame 3I/Atlas correctly. It's not just some random floating space rock. It is an ancient alien intruder that has been traversing the dark, completely empty void between stars for billions of years. And right now, as it brushes past our sun, it's waking up. It's actively leaving behind this incredible trail of clues for us to decipher.
So, let's get into Phase 1, the break-in. We're dealing with a cosmic speeder that absolutely does not belong here.
You know, when scientists track an object in space, the very first thing that tips them off to an interstellar origin is just the sheer unnatural physics of its arrival. The orbital mechanics of 3I/Atlas pretty much broke the mold the exact moment it was spotted by the Atlas telescope down in Chile. So the crucial point is that this object was clocked traveling at roughly 137,000 miles per hour relative to our sun. To put that massive scale into earthly metrics, that is over 170 times the speed of sound. It is moving so incredibly fast that our sun's immense gravity never even had a chance to capture it into a regular orbit.
And that insane velocity directly contributes to its record-breaking orbital eccentricity, which is 6.14. Just for some quick context, a perfectly circular orbit is 0. Anything over 1.0 is an open, hyperbolic trajectory. So at 6.14, 3I/Atlas has the highest known orbital eccentricity of any interstellar object we have ever observed. It mathematically proves that this visitor is on a one-way ticket. It's just passing through, and it will exit our solar system, never to return.
But honestly, it's the age that is truly staggering here. Scientists estimate this object could be up to 14 billion years old. Just think about that for a second. This visitor is a pristine relic from the cosmic noon period of intense star formation. It is potentially older than our entire solar system. I mean, our sun and Earth formed about 4.6 billion years ago, which means 3I/Atlas was already a wandering ghost for eons before our planet was even a speck of dust.
Moving on to Phase 2, the interrogation. This is where the comet finally starts to spill its secrets.
Way out in deep space, this ancient wanderer was perfectly frozen and completely silent. But as it dove deeper into our territory and got closer to the sun, the intense solar heat began to violently strip away its outer layers, basically forcing it to reveal exactly what it's made of. This happens through a really fascinating process called sublimation. That's the transition of a substance directly from a solid to a gas, entirely skipping the liquid phase. As 3I/Atlas neared the sun, the solar radiation flux hammered its icy surface. Instantly, those ancient ices sublimated, erupting into this massive 8,408-kilometer-wide gas cloud known as a coma that completely enveloped the nucleus.
Now, our own native comets, the ones born right here in our solar system, they're mostly water ice. But 3I/Atlas revealed an astonishing 8-to-1 ratio of carbon dioxide to water. That's roughly 89% CO2 and just 11% water. And this brilliantly illustrates that it is an extremely carbon dioxide-rich object, almost like a dangerously overcarbonated cosmic soda. This fact alone tells us it had to have formed in a uniquely cold environment, way, way beyond a star's snowline.
Actually, scratch that. The CO2 was really just the appetizer. Telescopes picked up a whole host of bizarre chemical clues. We saw this stunning green glow radiating from diatomic carbon. We measured an extreme deuterium to hydrogen ratio in its methane, which, by the way, is direct isotopic proof of a vastly different star system. We even found complex metals outgassing, like nickel and iron carbonyls. Add in an unprecedented negative polarization of -2.7%, which just refers to how its dust uniquely scatters light, and it becomes overwhelmingly clear the chemistry of this object is completely alien to anything in our local neighborhood.
Which brings us to Phase 3, the surveillance. This is when humanity basically turns every single camera to the sky.
Once astronomers realized the gravity of what they were actually looking at, the global scientific community rallied together. They turned every available camera, telescope, and spacecraft to the sky to track this frantic inner solar system tour before the comet vanished back into the dark.
Let's move to and see how this builds over time. Discovered in July 2025, it rushed past Mars by early October and hit its perihelion, its absolute closest approach to the Sun, by late October. It made its closest flyby to Earth at a perfectly safe distance in mid-December. But the real treat for astronomers came in January 2026. It entered a remarkably rare alignment directly with the Earth and the Sun, which allowed us an unparalleled dead-on view right down the comet's tail.
To capture all of this action, we've assembled an unprecedented global paparazzi fleet. We are talking the heavy hitters here, the Hubble and James Webb Space Telescopes, NASA's SphereX and Swift UV observatories. But what's absolutely mind-blowing to me is that we actually had interplanetary reporters on the scene. When it flew past Mars, ESA's Mars Express and China's Tianwen-1 Mars orbiter were literally watching it pass by from Martian orbit. We even pointed our massive radio dishes at it, like FAST and the Green Bank telescope.
Now, about those radio telescopes. Naturally, whenever something interstellar drops by, scientists will do their due diligence and check for alien technosignatures. They scanned it for artificial radio signals, and, well, spoiler alert, they found zero. It is not an alien spaceship. But honestly, the scientific reality is so much cooler. This is an ancient relic. Instead of a transmission, it gave us pristine cosmic chemistry. Hubble even captured a bizarre woggling jet shooting out from its nucleus, forming a rare antitail pointing directly toward the Sun. That's driven by complex dust physics and the comet's frantic, chaotic rotation.
And finally, Phase 4, the origin story. Echoes of cosmic noon. After all the tracking, the rigorous chemical analysis, and the spectacular multi-wavelength imagery, we're left to wonder, if it didn't come from our solar system and we know for sure it's not a spacecraft, where exactly did this ghost come from? Well, the research points to a profound conclusion. I'll read it right from the findings. It likely originated from the Milky Way's galactic thick disk during the cosmic noon period of intense star formation 9 to 13 billion years ago. Just let the philosophical weight of that sink in for a moment. Through our telescopes, we are quite literally touching a preserved fragment of an entirely different ancient star system, a planetary building block that was ejected into the dark long before our own world was even a thought.
Because of its extreme hyperbolic orbit, 3I/Atlas will never return. It's speeding away right now, continuing its endless voyage into the interstellar void. It's taking its secrets back into the dark, but it leaves us with an incredible, lingering question. 3I/Atlas will never return, but what other ghosts of the ancient universe are heading our way right now? If there are 3 confirmed, there are surely countless more silently crossing the abyss. Keep your eyes on the stars and stay curious.